Slides on air. This is relatively short. The ozone slides are relatively short as well, so that's why I'm having you do a couple of them in the same day. They're relatively short lectures. I used to have them as one, but I broke them up into two as it seemed a little bit better idea. I think the videos will probably just be one each, but we'll see. Right? So now that you've had a lot of background chemistry, we can talk about some things that apply. All right. So again, you want to do the slides along with the video so you can deal with it, so you can change things, and if there's some stuff embedded, you can look at that as well. So air is a mixture. It's a homogeneous mixture because if you look at air, it looks like it's one thing. It's mostly nitrogen, as you can see. It's about 78%. Then the rest of it is mostly oxygen, 21. So that's 99% of air. The last little bits are carbon dioxide and argon. Okay, that's naturally occurring pristine air. Of course, there's other things in there. All right. Now, if you click on this, it's a lot of pictures of Los Angeles over the years, and you have that little participation quiz, why are we regulated? So if you look at these slides, you'll see why we have regulations. Just a little history, Los Angeles had some big smog events in the 1940s and 1950s. The EPA is a federal organization that was created in 1970. California started its own regulations in the 60s. And the reason we did that is because California has several unique factors. One, typically we have the onshore flow, air moves towards the coast from the ocean. We have a lot of cars, which produce a lot of pollution. Of course, in the 60s, they did a lot more. But the other part is that because of our geography, the east of California has mountain ranges, and so air coming in gets trapped, and so we get a lot of smog, and stuff in the air gets stuck. If smog is produced in other states that are flat, like Kansas, for example, it just blows away. But in California, you've got the mountain ranges that hold it in. All right, so those of you guys are awfully young to remember this, but I can tell you when I was a little kid, we would drive from San Diego up to Los Angeles, and you literally could not see the mountains from the freeway because it would be so bad. And now, of course, you can. So we have regulations to clean things up. All right, when you read pollutants and things in the air, or any type of pollutants or environmental stuff, you'll see a couple of units. A percentage is a part per 100, so 78%. 78% nitrogen means for every 100 molecules in the air, 78 of them are nitrogen. Right? Parts per million is 1 out of a million, so 78 parts per million would be 78 out of a million. So parts per million and even parts per billion would be over a billion. They're useful when you're looking at small amounts of things. And it's important to remember as well that how much is a lot? And the answer to that question is it depends on what you're talking about. So some things, a lot is a lot. Some things, a very small amount can be very, very dangerous. So it just depends on what it is. The California emissions standards use grams per mile, and it's like per mile driven. To relate it to this, you would have to know how much gas comes out per amount of time, and then how much time and then how fast people are driving. So it's kind of a weird unit, and there's not really a clean conversion. But that's what the standards are. All right, so pollutants, by definitions, are things that are not supposed to be there. They're not naturally occurring, right, or naturally occurring at much smaller amounts. So the pollutants we're going to go through are carbon monoxide, oxides of nitrogen, particulates, oxides of sulfur, ozone, and what are called VOCs, volatile organic compounds. And we'll just go through each one of these separately and talk about them. All right. California's standard on carbon monoxide is 3.4 grams per mile. This is out of tailpipes. The sources of carbon monoxide are incomplete combustion of hydrocarbons. So your cars, gas grills, charcoal, things like that. If your heater is not adjusted appropriately, you're supposed to have a carbon monoxide detector in your home. That's California law now. And what it does is it attaches to hemoglobin. Hemoglobin is a molecule that carries oxygen in your bloodstream. Carbon monoxide binds to it instead of oxygen, and it binds 200 times better. So that means hemoglobin can't bind oxygen, and basically you smother. You can't transport oxygen, so first you get lightheaded, then the LD50. LD50 is the lethal dose for 50% of the population. 4,000 parts per million carbon monoxide is a lethal dose. And again, it's from incomplete combustion of hydrocarbons. And we've talked about combustion reactions in some earlier slides, so this is an application. So gasoline is a mixture, but it's got a lot of octane in it. And so this is when we burn gasoline, that's what we should get. That's assuming it burns completely. But if you burn it incomplete, it doesn't burn all the way. You get carbon monoxide, you get shorter chain carbon, which are called VOCs. You'll get just some carbon, right? And all this stuff comes down to be a particulate. Right? So your auto emission reports check for that. Right? So that's it. So that's the. And if you've ever been behind a car and you can smell the exhaust, right? These are odorless. All right. Now for nitrogen oxides, we just refer to them as NOx's. So in a car you're burning octane, and we get carbon dioxide and water, right? The car brings in air to provide the oxygen. But what's air mostly? Whoops. What's air mostly? Right? It's mostly nitrogen. Whoops. Back. And so you have a lot of nitrogen. Now nitrogen is extremely unreactive at normal temperatures, but at very high temperatures, it can actually burn. And so when you burn it, you can get this. You can play with it and balance it. All right? And you'll get nitrogen monoxide. You'll also get nitrogen dioxide. Right? It's a brown gas with an odor. And if you look at the brown stuff in the air in the smog slides, that's where you'll see it. That's what it looks like. There's your standard. LD50 is 1700. And it's nasty. It's a nasty gas. Smoke is, what is smoke? Okay, that's a picture of smoke. Smoke is unburned solids, so little things in the air, little bits of solids that aren't burned. They can be very, very small, so they're called particulates. And where can they come from? They can come from just dust, driving on a dusty road. Wind knocks things. Pollen is a particulate. You're always shedding skin cells, so they can be all sorts of things. All right. And it's categorized by size. So PM means particulate matter. The number is the size. So a micron is a millionth of a meter. So PM 2.5 would be even smaller. So what particulates can do, it depends on what they are too. Just the solids themselves can aggravate your lungs because that's what your body does. Your coughing tries to get that stuff out. Long-term exposure can coat your lungs, and the smaller particles can get deeper and deeper in. Right, so you can read that for yourself. Volatile organic compounds. So the word volatile means turns into a gas at a low temperature. You want a good example of a volatile, an organic compounds. We're going to talk about organic chemistry, but they're mostly carbon-based, and they have a lot of covalent bonds. And so these are things that like to be gases at room temperature, and they typically smell. All right. A good example would be a nail salon. If you walk into a nail polish remover is acetone. It turns into a gas at low temperature. You can smell it, and that means you're inhaling it. Right, so nail salons will have the particulates and they'll have VOCs. So particulates, right, that's what masks are for. They'll cut the particulates. The VOCs, though, a lot of those could go through a paper mask. So it just depends. There's the standard. Okay, and again, these, it depends on what it is. These are some examples, right? Overfilling your gas tank, bug spray or fertilizer sprays, spilled paint, nail polish remover, nail polish, things like that. Right? There's a whole set of slides on ozone, but ozone is a pollutant. So in the upper atmosphere, it protects us from UV. The lower atmosphere, it's nasty. It's highly reactive, and it's an oxidizer. Ozone's even used to kill bacteria at times. Oxidizer means it removes electrons from things. Looks like I forgot it. And we'll talk about oxidation and reduction later on. It's also part of smog. Right? The reaction is oxygen becomes ozone, and we'll look at that with the ozone slides. A good example where you would see or smell ozone right after a lightning strike, that kind of funny odor, that's what ozone smells like. All right, so this is a slide that just says pictures of it. So at low levels, it can damage forests. At high levels, it protects us from ozone, from ultraviolet. And these are some things that you can read about in terms of health risks. Okay? Most things are going to aggravate your lungs, are going to irritate your lungs. If you have lung diseases, they're going to make it worse. But over long terms, it can be really bad things. And again, it depends. If it's something that's toxic and will react with the tissue, that makes it worse. All right, oxides of sulfur. Anytime you dig something out of the ground, it's going to have some sulfur. So fossil fuels generally have sulfur. Coal has a lot of sulfur in it, or not a lot, but coal has sulfur. Sulfur is a yellow rock, Yellowstone. So these are the sulfur dioxide. You can read this from use in factories where they use a lot of coal for fires. Okay? And what it will do is it can react with water in the air. And these are acids, and we'll talk about acid-base chemistry later, but this is acid rain. If you want to see how we're doing, you could click on this slide. It has a lot of data. I took this from this link. You can see overall what's really nice, this is up to 2017, is that overall air pollution, you can see 1990. I don't know what the x-axis is. I'd have to look at what the number is. But, oh, this is these are deaths per 100,000 people. And you can see that the death rate has dropped, which means that air pollution has been decreasing. Why are we improving? That's right, regulations. Right? So regulations have positives and negatives, and you can get into the politics of that all you want. But regulations are put into place to cut down the amount of stuff that's put into the air. It'll be a very interesting discussion. That why are we regulated? All right. So just to summarize, major pollutants are caused by combustion reactions. So carbon monoxide from incomplete combustion of hydrocarbons, nitrogen oxides due to combustion of nitrogen in the air in internal combustion engines. Particulates can be from smoke, but they can also just be dust or things like that, pollens. And sulfur dioxide and sulfur trioxide are from burning sulfur, which is found a lot in coal. And then, of course, volatile organic compounds can be from incomplete combustion, also just on their own from spills and just chemicals that we use, and ozone as well are pollutants. All right, that's it for these slides. The material on this is on homework number 5. So that's the first part of homework 5.